Hello, so let's start the minimum cost of groups problem. It is also a heap based problem, and like here, what will be a brute force thinking? Like for brute force, you can think about like creating all the ropes pair, like creating all the merge, like trying all merge orders, like in whichever order it is possible, try to merge it and overall get the cost which is the minimum. So like for brute force, it will be, we can think like it is of recursion, like so it will take a factorial or we can say an exponential complexity. So like it will be a exponential, yeah, it will be an exponential. So instead of thinking in that direction, what we can think is like we can say 4326. So this is a classic greedy heap type problem, like to pick up the smaller two, then merge it with above it, like greater than that, and likewise. So let's proceed how to do that. Like I'm gonna show you a dry run. Like suppose first we take 2 plus 3, which will be 5, then 5 plus 4 will be 9. After that we have 9 plus 6 equal to 14 15, sorry, yeah. So 15 plus 5 plus 9, this will be total cost, which will be 29. Now let me take you the solution. Like before proceeding the solution, let's see the, like if we take the maximum, then will we get the answer or not? Like 4 plus 6 equal to 10, then 10 plus 4, which will be 14, and like 14 plus 2 equal to 16. So overall the cost will be like 16 plus 10 26 40. So you can try all approach, but it will be minimum if we select the smaller elements and merge them first, like a greedy way. So let's comment it all of this dry run, and let's proceed with the implementation part. So like as I told you, like the brute force, it will be like generating all the like trying all the merge orders. So how we can think of priority queue here, like heap, since we want minimum element at the top every time, so we can think of like it's a min heap. Like whenever we are placing the elements on always the minimum will be at the top. So let's declare a min heap vector, sorry, prior priority queue int comma pair, priority int comma vector of int comma greater int of, so it will be parity queue. Now we want to push all the array elements into the parity queue, like push all elements in pq so that they are arranged in ascending order, that is smaller at the top. For int I equal to 0, I less than n, I plus plus, and pq dot push array of I, but we need to have a variable n equal to array dot size. Like this we have done, and now we will take two elements at once and then merge them and again put them in back into the parity queue. Likewise we are doing here similar thing. So picking up the two elements at once. So like we are gonna check or we can say perform the operation until pq dot sorry pq not goes to empty, but here that condition will be wrong for like putting as the condition, since we always want two elements not a single element, so we have to ensure that priority queue has minimum size 2. So like pq dot size must be greater than 1. So we can now access the top two elements, like int top 1 will be pq dot top, then we have to pop that top element, so pq dot pop. Similarly we will get the top second element, pq dot top, again pop the accessed element, last accessed element. So we have got the top two elements, then we will calculate the cost as top 1 plus top 2, and like here we are adding at last. So here I am gonna like take a global total cost variable, and on the go I am gonna add the cost, total cost equal to 0. So like after cost, total cost will be plus equal to cost. So on the go it will be calculated. So after that we need to ensure that we push this to our new cost to our uh, priority queue pq dot push cost, and at last we can return the total cost. Let's say it runs fine or not. Yeah, it's working correctly. So talking about the time complexity, here we are basically pushing into the priority queue which will take a big O of n, since array has a size of n, and here the pop operation will like take for n elements. If pq means priority queue has n elements, then for each element we know it takes logarithmic of k time, like logarithmic of k for push as well as pop. So overall it will be for n elements it will be n into logarithmic of k, like n log k. So overall it will be like n log k plus n, so it will be n log k overall complexity. And no yeah, we have taken a priority queue, so it will be considered in space. So thank you.